Hey guys, welcome to our video on 10.2 ellipses. So very simply, let's jump into the definition. So an ellipse, why is it starting in red? An ellipse is simply a set of points whose sum of the distance from two fixed points is constant. So last time we had a parabola we talked about it had equal distance from this fixed focus point and this line that we call the directrix, right? Those two distances were equal for all points. With an ellipse, and I forgot the S, ellipse, all of the points have a fixed sum difference from two focal points. And we call each of those fixed points is called the focus. A focus. Or if we want to talk about them as a pair, plural, we say foci. Foci, whatever you want to call it. Now there's two different types of ellipse. So if you think of an ellipse, typically it is some sort of like kind of an oval. It can be a circle, depending on some values that we use. But we think of ovals, right? So kind of rounded and but not perfectly round, circular. And so those can either be kind of short and fat or tall and skinny, if you will. Short and fat is a horizontal major axis. So in other words, our two focal points fall on a horizontal line. Okay, so I'm going to label this out and kind of get it here. That's good. Now let's see if I can just drag it a little bit. Sometimes technology helps me out. All right. So this point right here, point negative a comma 0. This point here, a comma 0. And we've got negative c0. C0. Obviously, the distance here is c. The distance here is c. And this point here is the point 0 comma b and 0 comma negative b. Okay. This point and this point, all the vertices. Okay. Now let's look at the equation of this. Okay. We have a very kind of simple equation for an ellipse. It's x squared divided by a squared plus y squared divided by b squared, and that equals 1. And now for this to be a horizontal major axis, we have a big condition, and that is simply that a is greater than b is greater than 0. Okay. If this is the case, so if a is bigger than b, right? So a and b both have to be positive, and if a is bigger, we have a horizontal major axis, right? Short fat. And our vertices are 2. We have plus minus a comma 0. And so those are kind of the endpoints of our major axis. Now we also have what we call a minor axis. And so in this case, since this is a horizontal major axis, the minor axis would be our vertical. And so the endpoint for the minor axis would be 0 and plus minus b. Okay. And now our foci are, since this is a horizontal major axis, it's plus minus c comma 0. We're going to talk about how to find c in just a minute. Now, a vertical major axis is very similar. That's 2. Yeah, good enough. Okay. Our labeling here is going to be much the same. 0 comma a, 0, comma, negative A, 0, comma, negative B, 0, comma, negative B, comma, 0, sorry about that, B, comma, 0, and then again our two foci. We have this one here, which is 0, comma, C, and then this one here is 0, comma, negative C. Okay. Kind of the same thing, distance is C, right? Let's fix this one. Okay. Our equation here is slightly different. X squared over B squared plus Y squared over A squared equals 1. And again, A is greater than B is greater than 0. So what's kind of nice about this is whichever axis has the larger denominator value, right? Then that is going to be, so kind of whichever axes our major axis on, that means the denominator of that variable will have the larger of the two values. So this one here, vertical major axis, our major axis is vertical, so that's y-axis. So then the denominator of the y variable will have a larger value. Our vertices, as you can already tell, are 0, comma, plus minus a. Endpoints are plus minus b, comma, 0. And our foci, instead of c plus minus c0, are now 0, comma, plus minus c. So by labeling them this way and by thinking of them this way, it's really nice that you can kind of keep track, like vertices are the A's, endpoints are the B's, foci are always C's. And so you just have to kind of remember kind of whichever one's bigger is A, smaller is B. And so now how do we find our foci? Well, it's very simple. It follows this formula that we all know, but it's slightly different. So instead of a squared plus b squared equals c squared, it's a squared minus c squared, or minus b squared equals c squared. And c is greater than 0. Okay. So when you square root both sides, you don't have a plus minus issue, it's always positive. Now, those were two types of ellipses centered at the origin. And that's really nice. But life isn't always really nice. And so sometimes they aren't centered at the origin. So I think the battery in my pen is dying, and that's why I'm getting all these janky writings. So to kind of help us out, we kind of bring these as some extended lines. Okay, so this point right here is h comma k minus b. And this point up here, no, that's not. Sorry, that's at this point here. H comma k minus b, h comma k plus b. This point here is h plus a comma k, h minus a comma k, and then h minus c comma k, and h plus c comma k. Okay, so notice here our center, so this is h, okay, our center is at the point h comma k.